We are going to look at complex numbers, but before we actually get into it, I want you to think back to when you were in kindergarten. You probably only knew the numbers 1, 2, maybe up to 20. And then by the time you got into lower elementary, they expanded your understanding of numbers. They expanded your number system, and you probably could count into the hundreds. Well, by the time you got to some of the upper elementary grades, they expanded your number system again, and you probably learned about fractions. And when you get into middle school area, you started to learn about more numbers, and you were probably introduced to decimals and to negatives. So all your life, you've been expanding your number system, your understanding of numbers. We're going to be doing that same thing today. We're going to be expanding your number system. Okay, if you were to try to evaluate this, x squared is equal to negative 9. Well, we would start by applying the square root to both sides to get rid of the squared, and you would have x is equal to plus or minus the square root of negative 9. Now, if you try to type that into your calculator, it's going to give you an error. And you might be wondering, why isn't the answer negative 3? Well, if you were to take negative 3 times negative 3, you get a positive 9. So we can't actually find two regular real numbers that multiplied by itself will give you a negative 9. So in order to take care of this problem, we have introduced a new kind of number. It's called an imaginary unit, and we let I represent this imaginary unit. I is actually equal to the square root of negative 1. So go ahead and put a star by that, because that's going to be a big deal. We're going to use that a lot as we go on. Well, now if I is equal to negative 1, if I were to square both sides, I would have I squared is equal to negative 1, because on the right side here, the square and the square root would cancel each other out. So you would just be left with that negative 1. So put a big star by that one also, because that's going to be another thing that we use quite often. So we're going to be using the fact that I is equal to the square root of negative 1, and I squared is equal to negative 1. So now let's look at that problem again. If I try to evaluate x squared is equal to negative 9, I'm still going to square root both sides. And I'm going to be left with x equals plus or minus the square root of negative 9. Well, now I can break down that square root of negative 9 into the square root of negative 1 and the square root of 9, because negative 1 times 9 gives me that negative 9. And we just looked up here, I is equal to the square root of negative 1. So I'm going to replace that square root of negative 1 with an I. So I'm going to have plus or minus I square roots of 9. Now as I look at this, I realize I can reduce the square root of 9 to 3. So I'm really going to have x equals plus or minus I times 3. Now this isn't quite the normal way to write it. It would be similar to writing x times 2 instead of 2x. The second way here is considered normal. It's standard. This way it's not wrong, but it's just not kind of the standard way. And we have that same setup here. We generally put the real number in front. So the 3 is going to go in front. So we would end up with x equals plus or minus 3i. Now we're going to use these ideas to solve some quadratics. As I look at this first one here, I notice I have x only in one spot, so I can go ahead and do algebra. I am going to subtract 15 from both sides, so I would have 3x squared is equal to negative 6. Divide both sides by 3, and I'm going to get x squared is equal to negative 2. Now to get rid of that square, I square root both sides. So I'm going to have x is equal to plus or minus the square root of negative 2. Don't forget to do that plus minus, because we're the ones that applied the square root. Well, I notice I've got a negative in here again, so I'm going to break it down into the square root of negative 1 and the square root of 2. And then I'm going to replace that square root of negative 1 with what we just talked about on the last slide. Square root of negative 1 is actually I. So I'm going to have I square roots of 2. Now I need to look at my square root of 2 to decide if I can reduce that or not. Well, I can't break 2 down into any perfect squares, so I'm going to go ahead and leave my answer like this. Now on the last one I told you the number has to go in front. Well, when it's a square root, we usually leave it in the back. So we would leave the I out front here and we would have x equals plus or minus I square roots of 2. Okay, on our second one here, I am going to go ahead and add 8 to both sides because I only have x in one spot, so I can do my algebra. And I end up with 4x squared is equal to negative 14. Divide both sides by 4, and I'm not allowed to have the decimals, remember. So I'm going to leave it as negative 14 over 4, but then I'm going to go ahead and reduce that to negative 7 over 2. Then I have to get rid of the square. So to get rid of the square, I square root both sides, and I'm left with x is equal to plus or minus the square root of negative 7 over 2. Now this answer has a couple problems. First one is we're not allowed to leave that negative sign under the radical. The second one is we're not allowed to have a radical for a denominator either. So here you have a couple different options of how you want to break it apart. I'm going to go ahead and take care of the radical in the denominator first. So I'm going to break this up into the square root of negative 7 over the square root of 2. And then I'm going to rationalize my denominator by multiplying by the square root of 2 over the square root of 2. And when I do that, I get plus or minus the square root of negative 14 over the square root of 4. And square root of 4 is just a plain 2, so I end up with the square root of negative 14 over 2. Now I can go ahead and take care of that negative problem. So when I break down that negative 14, I'm going to go over here to break that down. I'm going to break it down into the square root of negative 1 times the square root of positive 14. Then my square root of negative 1 turns into an I. And then I need to check, can I break my 14 down into any perfect squares? And the answer is no. So when I'm finally said and done with this one, I'm going to have x equals plus or minus I square roots of 14 all divided by 2. Okay, so now we're going to look at complex numbers. In this sense, complex does not mean hard. It means non-real or imaginary. So a complex number is in standard form when we have a plus bi. A is called the real part, and the bi is called the imaginary part. Now to be in standard form, you have to have them separated by each other. And then one thing that is sometimes confusing is it says that a and b are real numbers. Well, I just got done telling you that bi is the imaginary part. What this means is that we might have some numbers like 3 plus 4i. In this case, b is 4. Well, 4 by itself is a real number. But when you have 4i, that gives you an imaginary part. So 3 plus 4i would be a complex number in standard form. It can also be minuses. So we could have 2 minus 6i. Our real part would be the 2. Our imaginary part would be the 6i. If you just have something like 4i, well, if you want it to look like it's in complex form, our real part would have to be 0. So we would have 0 plus 4i. Now we're going to look at how to plot these complex numbers. Now when we plot them, we can't plot them on a normal Cartesian graph because that was only involving real numbers. So what we have to do is we have to plot them on a complex plane. It still works in the same type of way. Across the x-axis, I have my real numbers, so we call that our real axis. And what was our y-axis, we now have our imaginary units. So that would be our imaginary axis. When I go to plot a number, let's say I want to plot 3 plus 2i. I treat it just like I would an xy coordinate. So I'm going to go over to 3 on my real axis, and then I'm going to go up to 2i and plot my point. If I wanted to plot just 4, well, I would go over to 4 on my real axis because the 4 is a real part, and then I wouldn't go up or down because I don't have an imaginary component. And if I wanted to do 1 minus I, well, I would go to the right 1, and then the minus I indicates that I go down 1I. And the last one, if I wanted to plot the point 2I, I have no real component, so I don't move right or left, and I would just go up to the 2I to plot the point. So plotting your complex numbers is similar to plotting on the regular XY coordinate, but now we just have a real and imaginary part.